Today, we'll be solving a quadratic equation problem using the discriminant. Let's solve. Our question is, find the set of values of k for which the line y equals 2x plus k cuts the curve y equals x squared plus kx plus 5 at two distinct points. So, first, we need to mark our line y equals 2x plus k as equation 1 and curve y equals x squared plus kx plus 5 as equation 2. Next, we'll put equation 1 into equation 2. Substitute y in curve with 2x plus k from the line. So, we'll put 2x plus k equals x squared plus kx plus 5. Then, we'll need to move 2x plus k to be with x squared plus kx plus 5 and equate everything to 0. From ax squared plus bx plus c equals 0, our a is equals to 1, our b is equal to k minus 2, and our c is equal to 5 minus k. Recall that we used the quadratic formula to find the x-intercepts of a quadratic function. From this formula, x equals minus b plus or minus square root b squared minus 4ac over 2a, b squared minus 4ac is called the discriminant. The discriminant is useful because it tells us the nature of the solutions of a quadratic equation. For the equation ax squared plus bx plus c equals 0, if the discriminant is greater than 0, then there will be two distinct real solutions. If our discriminant is lesser than 0, then there will be no real solution. And if our discriminant is equal to 0, then there will be one distinct real solution. Since the question says it cuts at two distinct points, we will use b squared minus 4ac is greater than 0. Then, we'll substitute our a, b, and c into our discriminant. That would give us k minus 2 squared minus 4 times 1 times 5 minus k is greater than 0. Our next step is to expand and add or subtract. So, if we expand that, we will get k squared minus 4k plus 4 minus 20 plus 4k is greater than 0. We'll cancel or subtract minus 4k and plus 4k. We'll also add plus 4 and minus 20. That would give us k squared minus 16 is greater than 0. So, k squared minus 16 is greater than 0 can be changed into k minus 4 times k plus 4 is greater than 0. So, we need to clarify how much is the value of k that touch at 2 points. Let k minus 4 times k plus 4 equals to 0. So, if that happens, k would be equals to 4 and negative 4. We'll also need to draw a number line and use test points to check. Here's our number line, and here's the list of test points to use. Let's first start at minus 4. So, minus 4 squared minus 16 is greater than 0. That would give us 16 minus 16 is greater than 0, and 0 is not greater than 0. So, we'll mark this as false. And on there, we'll just put an open circle. For 4 squared minus 16 is greater than 0. 16 minus 16 is greater than 0. That is not simply true because 0 is not greater than 0, so that's false. We'll also mark it with an open circle. Next is 0. So 0 squared minus 16 is greater than 0. That would give us negative 16 is greater than 0. That's totally false. So we'll just mark that with an X. And then we'll use minus 5. Minus 5 squared minus 16 is greater than 0. That would give us 25 minus 16. 9 is greater than 0. That is true. So we'll mark negative 5 with a tick. And then our last test point is 5. 5 squared minus 16 is greater than 0. That would give us 25 minus 16 is greater than 0. Also, 9 is greater than 0. That is true. And we'll mark that. That's it. So what does this tell us? It tells us that our value of k must be greater than 4, or our value of k must be lesser than negative 4. So our final answer is k lesser than negative 4 or k greater than 4. And we did it. After we did it, we need to check our answer in decimals. So in decimals, we can add a slider for k. Now our k value is more than negative 4 and less than 4. That's why it doesn't touch our curve. If we change our value into 4, you can see that it touches once. Also the same for negative 4, it also touches once. But once we change that to negative 5, we can see that it touches the curve at 2 points. Same goes for 5. So from our answer, we can say that when k is greater than 4 or k is lesser than negative 4, it touches twice. When k is equal to 4 or k is equal to negative 4, it touches once. And when k is between negative 4 and 4, it doesn't touch. So that's our conclusion for our equation. So thanks for watching.